All right, welcome to this explainer. Today, we're basically declassifying the physics and chemistry behind engineering the absolute ultimate homemade peanut butter cup. You know, if you've ever tried to make these at home, you already know it's weirdly hard to get them exactly right. But today, we are breaking down the precise scientific protocol from our source material to pretty much guarantee success. So here's the big question we're tackling right out of the gate. How do you perfect a peanut butter cup without just dumping in like cups and cups of powdered sugar? We really want to mimic that perfect, dry, crumbly texture you get from the commercial brands. And honestly, the answer lies in a truly fascinating scientific hack. Okay, here's our tactical protocol for today. We've got Phase 1, Rheological Seizure, Phase 2, the chocolate exoskeleton, Phase 3, cryogenic assembly, and finally, Phase 4, the Red Team Report. All right, let's jump right into Phase 1, Rheological Seizure, where we build the core. Now, our secret weapon here is triggering a deliberate rheological seizure. It sounds intense, right? Basically, we are weaponizing moisture to thicken a fat. By introducing water into natural peanut oils, the proteins and starches rapidly swell and clump up. It instantly transforms what starts as a runny nut butter into a stiff, totally moldable dough. To pull this off, you absolutely have to stick to the parameters you see here. You'll need a half cup of 100% natural stir-top peanut butter. It has to be liquid at room temp and 0 palm or hydrogenated oils allowed. You're going to combine that in a mixing bowl with 2 to 3 tablespoons of pure grade A dark maple syrup, a half teaspoon of vanilla extract, and a heavy pinch of flaky sea salt. Once all that is in the bowl, you need to stir it vigorously. And I mean vigorously. You've got this tight target window of just 15 to 30 seconds before you'll feel a massive, sudden increase in viscosity. The physics at play here are just brilliant. The water hidden inside that maple syrup literally disrupts the continuous oil phase of the peanut butter. It basically forces the solid peanut particles to suddenly stick together. You'll literally see the whole mixture pull away from the sides of the bowl and turn into this matte, workable dough. Okay, so once you've got that dough, we have to lock in its new thermal structure. You do this by rolling it out into 12 small, flattened discs. Pop them onto a parchment-lined plate and throw them straight into the freezer for exactly 15 minutes. Moving on to Phase 2, the chocolate exoskeleton, or what we're calling the lipid-modified shell. Now you might be sitting there thinking, hey, can't I just melt some chocolate chips and call it a day? Well, actually, no. Pure melted chocolate is incredibly brittle. If you just freeze pure chocolate, it turns into glass and completely shatters on impact. If you bit into that, it would literally squeeze your carefully crafted peanut butter payload right out the sides. Total disaster. So, to hack the exact bite coefficient of a commercial cup, that soft, yielding snap we all love, we have to chemically modify our chocolate. You're going to need 8 ounces of high-quality 70% dark chocolate, plus our crucial second ingredient, exactly 1 tablespoon of virgin coconut oil. Here's the chemistry behind why that works. Adding that single tablespoon of coconut oil actively lowers the melting point of the entire chocolate matrix. So when it's frozen and you take a bite, it yields softly to your teeth instead of just snapping and fracturing. The best part? We completely bypass the nightmare of complex thermal tempering with this super straightforward hack. You just combine the chocolate and coconut oil in a glass bowl and microwave it in highly controlled, strict 30-second bursts at 50% power. Just make sure you stir thoroughly between every single burst until the whole matrix is smooth and glossy. Trust me on this one. All right, we're ready for Phase 3, cryogenic assembly and preventing structural collapse. First up, let's prep your hardware. Your assembly bays are going to be a standard 12-cup mini muffin tin, properly outfitted with paper or silicone liners. Now, the absolute crucial point in this assembly is establishing your foundation. You lay down the base by spooning 1 teaspoon of your melted chocolate matrix right into the liner. You've got to tap the tin firmly on your counter to level the liquid perfectly. Next is what we're calling cryostasis 1. Freeze that tin for 5 minutes until it's solid. Once it is, grab your frozen peanut butter discs and precisely center one onto each hardened base. It's incredibly important to leave a distinct gap all around the edges of your payload. Okay, let's lock it down with the seal. Spoon 1.5 teaspoons of chocolate over the top, making sure it flows down those sides to completely encapsulate the peanut butter disc. Tap the tin repeatedly to knock out any trapped air bubbles. Finally, hit each cup with a single flake of sea salt and put them into cryostasis 2. That's a final 15 to 20 minute freeze to permanently set the exoskeleton. Almost done. Let's hit phase 4, the red team report, where we do some counter-analysis and troubleshooting.
Take a look at this comparison. If you use natural stir-top peanut butter, literally just peanuts and salt, you trigger that perfect seizure we talked about. But if you try to take a shortcut with a heavily processed commercial brand, the mission will absolutely fail.
The source material actually calls this the Jif/Skippy failure. If you mix a heavily processed commercial peanut butter with maple syrup, it completely degrades into this unworkable, runny, overly sweet slime. It just flat out refuses to hold a shape. And the text actually tells us exactly why this happens. Commercial emulsions are chemically locked at the factory. They are literally engineered with hydrated vegetable oils and emulsifiers, things like mono and diglycerides. And those additives, they are specifically designed to prevent the exact moisture-seizing process we are actively trying to achieve. Crazy, right?
Finally, keep an eye out for the blooming defect. If you ever notice white, dusty streaks on your chocolate shell, that's just cocoa butter separating because of temperature fluctuations. Since we totally skipped complex thermal tempering earlier, your strict protocol correction here is thermal control. You must store the finished cups consistently in the fridge at 38 degrees Fahrenheit.
So the protocol is officially in your hands. All the variables are defined. The only question left is, will you master the physics of the rheological seizure, or will you succumb to the commercial peanut butter slime? Are you ready to head into your kitchen, weaponize some moisture, and engineer the absolute perfect peanut butter cup? I highly recommend you test this experiment out for yourself. Thanks so much for joining me on this explainer, and hey, happy assembling.